You've seen it before, that massive striped planet floating silently in the darkness. But what you think you know is only the surface, because Jupiter is not just big, it's strange, violent, and completely different from anything on Earth. Its storms never stop, its gravity changes everything, and deep inside, there's no ground at all. But here's the truth. The deeper you learn about Jupiter, the less it makes sense. Welcome to Falling into Space. And if you enjoy discovering the hidden secrets of the universe, don't forget to subscribe, because tonight, you're not just learning facts, you're uncovering something much bigger. You are looking at a planet, but it doesn't behave like one. From a distance, Jupiter seems calm, a giant sphere wrapped in soft bands of color, slowly rotating in the darkness. Beautiful, almost peaceful. But that calm is an illusion, because Jupiter is not a solid world. It is a system of storms, of pressure, of forces that never stop moving. And the closer you look, the stranger it becomes. Jupiter is the largest planet in the solar system. Not slightly larger, not moderately bigger, massive. More than twice as massive as all the other planets combined, which means its gravity is unlike anything else nearby. It dominates everything around it. Asteroids, comets, even smaller planets in the past, all shaped by Jupiter's presence. But its size is not the most surprising part. The real mystery begins when you ask a simple question. What is Jupiter actually made of? Because unlike Earth, there is no surface, no ground to stand on, no solid layer where the planet begins. Instead, Jupiter is made mostly of gas, hydrogen and helium, the same elements that make up stars. Which means, if you tried to land on Jupiter, you couldn't. You would fall, and keep falling. But before that happens, something else becomes impossible to ignore. The storms. Jupiter's atmosphere is alive, not in the way life exists on Earth, but in the way it moves, constantly, endlessly. The clouds you see from space are not static. They are bands of gas moving at incredible speeds, hundreds of kilometers per hour, flowing in opposite directions, creating boundaries where energy builds, where turbulence forms, where storms are born. And some of those storms never end. The most famous one is the Great Red Spot, a storm so large it could swallow Earth, and it has been active for more than 300 years. Think about that. A single storm, lasting longer than human civilization has existed in its modern form. And it is not alone. Jupiter is covered in storms, some large, some small, all moving, all interacting, all part of a system that never stops. And yet, this is only the outer layer. Because the deeper you go into Jupiter, the less it behaves like a planet, and the more it begins to feel like something else. The temperature changes, the pressure increases, the gas becomes thicker, heavier, more difficult to move through. At first, it feels like an atmosphere, like clouds, like something you could imagine passing through. But that doesn't last, because Jupiter does not have clear layers like Earth. It transitions from gas to something denser, from something light to something heavy. And eventually, the hydrogen itself begins to change. Under extreme pressure, hydrogen is forced into a new state. Metallic hydrogen. A form of hydrogen that behaves like a liquid metal. conducting electricity, moving like a fluid, existing under conditions that cannot be recreated easily on Earth. And this is where Jupiter becomes truly strange. Because this metallic layer is massive, it surrounds the deeper regions of the planet, and it is responsible for something incredible: Jupiter's magnetic field. The strongest magnetic field of any planet in the solar system. So strong that it creates a region around the planet where charged particles are trapped and accelerated. A radiation environment so intense that it would destroy anything unprotected that enters it. This is not just a planet. It is an environment, a system, a structure that behaves more like a failed star than a typical world. Because Jupiter almost became a star. If it had been slightly larger, if it had gathered more mass during its formation, it could have ignited nuclear fusion. It could have become a second sun. But it didn't. And what remains is something in between. Not a star, not a solid planet. Something else. Something that challenges the way you think about worlds. And yet, even with all of this, there is still something deeper. Because scientists are still not entirely sure what exists at Jupiter's core. There may be a dense region, a mix of rock and metal, or it may be something less defined, a fuzzy core that blends into the surrounding layers. But reaching it is impossible. Because the deeper you go, the pressure becomes overwhelming. Millions of times stronger than Earth's surface pressure. Enough to crush anything, enough to transform matter itself. And that is what makes Jupiter so fascinating. Not just its size, not just its storms, but its depth. Because it hides everything beneath layers that cannot be explored directly. Layers that force you to imagine, to calculate, to guess. And every time you think you understand it, something new appears, something unexpected, something that makes it even more mysterious. Jupiter is not just a giant planet. It is a world without a surface, a place where falling never stops, a system where storms last for centuries, a structure where matter behaves in ways you cannot see anywhere else. And this is only the beginning. Because the deeper you go into Jupiter, the more impossible it becomes. You are still looking at the same planet, but now the scale begins to change everything. From far away, Jupiter is just a sphere in space. Large, yes, but still something your mind can contain. Something you can compare to Earth. But the closer you examine it, the more that comparison breaks. Because Jupiter is not just bigger. It operates on a completely different level. Let's start with its gravity. On Earth, gravity feels constant, predictable. You know what it does. You feel it every second, but you don't think about it. On Jupiter, that feeling would be overwhelming. If you could stand on Jupiter, which you can't, you would feel more than twice your weight, not instantly crushing, but heavy enough to change how everything moves, how everything behaves. But the real effect of Jupiter's gravity is not what it does to you. It's what it does to everything else. Jupiter acts like a giant shield, and sometimes a threat. Its gravity is so strong that it captures objects from across the solar system. Asteroids, comets, fragments of rock and ice that drift too close. Some are pulled into orbit around Jupiter. Others are accelerated, redirected, sent into new paths, and some are pulled directly into the planet itself. You are not just looking at a planet. You are looking at something that shapes the solar system. There is a region in space known as the asteroid belt, located between Mars and Jupiter. And one of the reasons that belt exists is because Jupiter's gravity prevented those rocks from ever forming a planet. It disrupted them, kept them from coming together. Which means Jupiter didn't just form as a planet. It influenced the formation of other planets. And it still does. From time to time, objects collide with Jupiter, massive ones. In 1994, something extraordinary happened. A comet, known as Shoemaker-Levy 9, was pulled apart by Jupiter's gravity, broken into fragments. And then, those fragments fell into the planet, one by one. Each impact created explosions larger than anything ever seen on Earth. Marks appeared on Jupiter's surface, visible even from telescopes. Temporary scars on a planet that usually hides everything beneath its clouds. And then they disappeared. Because Jupiter does not keep evidence for long. Its atmosphere is too active, too dynamic. Everything is erased. This is what makes Jupiter so strange. Events happen, but they don't stay. Storms form, grow, merge, fade. Impacts occur, then vanish. Nothing remains stable for long. And yet, the system continues. Now, let's look at something even more unusual. Jupiter spins, but not in the way you expect. A day on Jupiter lasts less than 10 hours. That means this massive planet, the largest in the solar system, rotates faster than Earth. Faster than almost any other planet, which creates something extraordinary. The bands you see across Jupiter are not just clouds. They are the result of that rapid rotation. Different layers of the atmosphere move at different speeds, in different directions. This creates powerful jet streams, wrapping around the entire planet. These streams separate the cloud bands, creating the striped appearance you see from space. Light bands, dark bands, all moving, all interacting, all part of a system driven by rotation and energy. And within those bands, storms form, constantly. Some are small, some grow into massive systems. Some merge, creating larger structures, like the Great Red Spot. But even that storm is changing. It has been shrinking over time. Still enormous, still powerful, but not permanent. Nothing on Jupiter is permanent. Now, let's go even deeper into what makes this planet so extreme. Jupiter emits more heat than it receives from the sun. Think about that. It generates its own energy. Not enough to become a star, but enough to affect its entire structure. This internal heat rises through the planet, feeding storms, driving motion, creating the dynamic system you see on the surface. Which means, even without the sun, Jupiter would still be active. Still moving, still changing. This is why its atmosphere is so powerful. It is being driven from both directions. Heat from below, energy from above. And between those forces, chaos forms. But controlled chaos. Because despite everything, despite the storms, the impacts, the constant motion, Jupiter remains stable as a whole. Its orbit is steady. Its structure holds together. Its gravity keeps everything in balance. It is both chaotic and stable. And that contradiction is what makes it so fascinating. Because Jupiter is not simple. It is not just a gas giant. It is a system of forces interacting constantly, creating something that is always changing, but never collapsing. And yet, there is still more. Because everything you've seen so far is only the outer behavior. The visible part, what lies deeper, is even more extreme. Because the further you go into Jupiter, the less it behaves like anything you've ever known. And the more it begins to feel like something you were never meant to understand. You are still looking at Jupiter, but now you begin to understand that what you see is only a surface illusion. Those bands, those colors, those endless storms, they feel like the planet itself, but they are not. They are only the outermost expression of something far deeper, a thin, visible layer hiding an environment that becomes more extreme with every kilometer you imagine descending. And the deeper you go, the less Jupiter behaves like anything familiar. The clouds thicken. At first, they look soft, almost gentle, but that softness disappears quickly. The gas becomes denser. The movement becomes heavier. The atmosphere is no longer something you could drift through. It pushes back. It resists. It surrounds you completely. Light begins to fade, not because there is nothing to illuminate, but because the atmosphere itself absorbs and scatters it. The deeper layers block sunlight entirely. Everything becomes darker, more muted, until eventually the idea of day no longer exists. And yet, the motion continues. The storms above do not stop just because you cannot see them anymore. Their energy travels downward, feeding the layers below, shaping currents that stretch far beneath the visible atmosphere. This is not just weather, it is structure. The pressure increases, slowly at first, almost unnoticeable, then more rapidly. Each layer adds more weight, more force, more compression. The gas is no longer behaving like gas. It becomes thick, almost fluid, something that flows but with resistance. Movement becomes harder, not because gravity has changed, but because the environment itself does not allow free motion anymore. And still, there is no surface, no boundary, no point where the atmosphere ends and something solid begins. Only deeper layers, each one more extreme than the last. The temperature rises, not gradually, but significantly. The deeper you imagine going, the hotter it becomes. Heat from Jupiter's interior moves upward, combining with the pressure around you to create conditions that cannot exist on Earth. And this is where Jupiter begins to change completely. Hydrogen, the most common element in the planet, no longer behaves the way you expect. Under these conditions, it is compressed so intensely that its structure changes. It becomes metallic. Not solid metal, not something you could touch, but a liquid that conducts electricity. Imagine an ocean, not of water, but of liquid metal, stretching across a massive region deep inside the planet. That is what exists within Jupiter. This metallic hydrogen layer is enormous. It surrounds the deeper regions, extending across distances larger than entire planets. It moves slowly, influenced by heat, by pressure, by rotation. And as it moves, it generates something powerful: Jupiter's magnetic field. This field is not just strong, it is enormous, the largest structure in the solar system. If you could see it, it would stretch far beyond the planet itself, capturing charged particles, accelerating them, creating a radiation environment so intense that it would destroy anything unprotected. This is why Jupiter is not just dangerous near its surface, it is dangerous far beyond it. Its influence extends into space. The region around Jupiter is filled with radiation, trapped by its magnetic field, moving at incredible speeds. Any spacecraft entering this region must be designed to survive it, to resist it, to function within it. And even then, it is not easy. This is not a place where things survive easily. Now, go deeper, past the metallic hydrogen, into regions that are even more difficult to imagine. Because beyond that layer, scientists believe there is a core, but not a simple one, not a solid sphere like Earth. Instead, something far less defined. A fuzzy core. A mixture of heavier elements, rock, metal, materials that have been compressed, heated, and partially dissolved into the surrounding layers. It is not separate. It blends into the planet. Which means there is no clear boundary, no moment where you could say, this is the center. Only a gradual increase in density, in pressure, in temperature, until everything becomes part of the same system. And at that depth, conditions reach their most extreme. Pressures millions of times greater than Earth's surface, temperatures hotter than the surface of the sun. And still, Jupiter holds together. It does not collapse. It does not explode. It remains stable because the forces within it are balanced. Gravity pulls inward, pressure pushes outward, heat moves through the system, rotation shapes the structure. Everything works together to maintain a planet that should not feel stable, but is. This is what makes Jupiter so extraordinary. It exists at the edge of what a planet can be. Too massive to be simple, not massive enough to become a star. A world in between. And everything you have seen, everything you have imagined descending through is part of that balance. The storms above, the pressure below, the metallic hydrogen, the hidden core, all connected, all part of a system that has existed for billions of years and will continue long after everything on Earth is gone. Jupiter does not just exist, it endures. And the deeper you understand it, the more it feels like something far beyond a planet, something that challenges the idea of what a world can be. And this is still not the end of its story. You are still looking at Jupiter, but now the focus shifts away from what is inside it and toward what surrounds it, because Jupiter does not exist alone. It dominates an entire system around it. Far beyond its thick atmosphere, beyond its radiation belts, beyond the invisible boundary of its magnetic field, there is a region filled with objects that are constantly being shaped by its gravity. Moons. Not just one or two, dozens, more than any other planet in the solar system. Some are small, irregular, captured fragments of rock that were pulled into orbit long ago, but others are something far more extraordinary. The 4 largest moons of Jupiter, known as the Galilean moons, are not just satellites, they are worlds. Each one different, each one unique, each one shaped by Jupiter's immense gravitational pull. Start with Io. At first glance, it does not look like a moon. It looks like something broken, something constantly changing. Because Io is the most volcanically active world in the solar system. Its surface is covered in lava flows, sulfur deposits, massive eruptions that reshape it again and again. And the reason is Jupiter. The planet's gravity pulls on Io constantly, but not evenly. As Io moves through its orbit, the strength of Jupiter's pull changes slightly. This creates internal friction, heat, energy. And that energy powers volcanoes across the entire moon. Io is not stable. It is being stretched, compressed, heated, continuously. A world that cannot rest. Now look at Europa. Completely different. Smooth, bright, covered in ice. At first, it seems calm, frozen, dead. But beneath that ice, there is something hidden. An ocean. A global ocean of liquid water, kept from freezing by the same gravitational forces that affect Io. Tidal heating, generated by Jupiter's pull, keeps the interior warm enough for water to remain liquid. Which means Europa may have the conditions needed for life. Not on the surface, not in the way you know, but beneath the ice, in darkness, in an environment that has existed for billions of years. A hidden world. Now, Ganymede, the largest moon in the solar system, bigger than Mercury. And it has something no other moon has, a magnetic field, which means it behaves in some ways like a planet. Its interior is complex, layered, active, and yet it still exists under Jupiter's influence. Even something this large cannot escape it. Finally, Callisto, the most distant of the four, and the most heavily cratered. Its surface is ancient, almost unchanged for billions of years. A record of the solar system's history, preserved in impact marks that have never been erased. Unlike Io, which is constantly renewed, unlike Europa, which hides an ocean, Callisto remains still, untouched. But all of these moons, no matter how different, share one thing. They exist because of Jupiter. Its gravity captured them, shaped them, defined their behavior. Without Jupiter, they would not be what they are. And beyond these major moons, there are many more. Smaller objects, irregular shapes, fragments captured from across the solar system. Some orbit in strange directions, some follow unusual paths, all held in place by a force that dominates everything nearby. This is not just a planet with moons. This is a system, a miniature solar system centered around Jupiter. And it does not stop there. Jupiter's influence extends even further. Its gravity affects the asteroid belt. It shapes the paths of comets. It protects the inner planets by pulling dangerous objects away, or sometimes sending them inward. It is both a shield and a threat, a guardian and a disruptor. And this dual role makes it one of the most important objects in the solar system. Because without Jupiter, Earth's history might have been very different. More impacts, more instability, more chaos, or perhaps fewer opportunities for life to survive. Jupiter's presence has shaped everything, not just its own system, but the entire structure of the solar system itself. And yet, for all its size, for all its power, for all its influence, Jupiter remains what it has always been: a giant world of gas, a planet without a surface, a system of storms, pressure, and hidden layers, surrounded by worlds that are just as strange, just as fascinating, just as impossible to fully understand. And the more you explore it, the more you realize something unexpected. Jupiter is not just a planet. It is a boundary, a line between the inner solar system and everything beyond, a force that shapes the space around it, a world that influences everything without ever needing to change itself. And even now, after everything you have seen, everything you have learned, there is still more. Because Jupiter is not finished revealing its secrets. It never will. You are still looking at Jupiter, but now the focus shifts to something you cannot see directly. Not its storms, not its clouds, not even its massive size, but the invisible force surrounding it. Because Jupiter does not just exist as a physical object, it exists as a field, a region of influence that stretches far beyond the planet itself. Jupiter's magnetic field is not just strong, it is enormous. So large that if it were visible from Earth, it would appear bigger than the moon in the night sky. Imagine that. An invisible structure surrounding a planet, extending millions of kilometers into space. And inside that structure, something dangerous happens. Charged particles are trapped, accelerated, forced to move along invisible lines of energy. These particles come from different sources, some from the sun, some from cosmic radiation, some even from Jupiter's own moons, like Io, which releases material into space through its constant volcanic activity. All of these particles become part of Jupiter's magnetosphere, and once they are inside, they cannot escape easily. They move at incredible speeds, colliding with anything that enters the region. This creates one of the most extreme radiation environments in the solar system. If a human spacecraft entered this region without protection, it would not survive long. Electronics would fail, systems would shut down, radiation would damage everything. Even modern spacecraft, designed to study Jupiter, must be carefully planned to avoid spending too much time in these regions, because the environment is not just hostile, it is relentless. And yet, this same system creates something beautiful. Auroras. Much like the auroras on Earth, Jupiter has its own, but they are far more powerful, far more constant. At its poles, the magnetic field channels charged particles into the atmosphere, creating massive glowing regions. These auroras do not come and go like Earth's. They are always there, always active. A constant display of energy, driven by the planet's magnetic field and its interaction with space. And this is where Jupiter becomes something more than a planet. It becomes a generator, a system that converts motion, rotation, and internal energy into electromagnetic force. Because Jupiter spins incredibly fast, less than 10 hours for a full rotation, this rapid motion, combined with the movement of metallic hydrogen deep inside the planet, creates electric currents. Those currents generate the magnetic field, and that field shapes everything around it. It captures particles. It creates radiation. It forms auroras. It defines the space around Jupiter. But the influence does not stop there. Jupiter interacts with its moons, not just through gravity, but through this magnetic field. Io, the volcanic moon, feeds material into Jupiter's magnetosphere. That material becomes ionized, charged, and trapped within the field. Europa, Ganymede, Callisto, all move through this environment, affected by forces that cannot be seen. Energy flows between the planet and its moons. Invisible connections. A system that is constantly exchanging energy, matter, and motion. This is not a simple planet with satellites. This is a complex network, a structure where everything is connected. And yet, even with all of this, Jupiter remains stable. Its magnetic field continues. Its rotation remains constant. Its system holds together for billions of years. And it will continue long into the future. Because Jupiter is not changing in the way smaller planets do. It is too large, too massive, too stable. While Earth evolves, changes, loses its oceans, transforms completely over time, Jupiter remains. Its storms shift. Its structure evolves slightly, but its overall existence continues. It will outlast many of the changes happening elsewhere in the solar system. And this leads to something important. Jupiter is not just a part of the solar system. It is one of the reasons the solar system exists in its current form. Its gravity shaped the early formation. Its presence influenced the distribution of material. Its magnetic field creates one of the most extreme environments in space. And its stability ensures that it will remain a dominant force for billions of years. But even something this powerful is not completely untouchable, because the solar system itself will change. The sun will evolve. The inner planets will transform. The balance will shift. And when that happens, even Jupiter will feel it. Not immediately, not dramatically, but inevitably, because nothing in the universe exists forever in the same state. Even the largest planet, even the strongest magnetic field, even a world as powerful as Jupiter, will one day face change. But for now, it remains. A giant in space, a system of storms, radiation, and invisible forces. A planet that does not just exist, but dominates everything around it. And even now, there are still secrets hidden within it. Secrets that may never be fully understood. Because some worlds are simply too vast, too complex, too extreme to ever be completely known. You are still looking at Jupiter, but now something deeper begins to feel unsettling, not because of what it does, but because of what it almost became. When Jupiter was forming billions of years ago, it had the potential to become something far more powerful than a planet, something far more dangerous. A star. At the beginning of the solar system, clouds of gas and dust collapsed under gravity, forming the sun at the center and the planets around it. Jupiter formed in that same environment, gathering massive amounts of hydrogen and helium, more than any other planet, far more. And for a brief moment in cosmic terms, it was close. Close to becoming something else. Because stars are not created by magic. They are created by mass. When enough material gathers in one place, gravity compresses it, pressure builds, temperature rises, until something critical happens. Nuclear fusion begins, and a star is born. Jupiter did not reach that point. It is massive, but not massive enough. To become a true star, it would need at least 80 times its current mass. But there is something in between. A class of objects known as brown dwarfs, failed stars. Objects that are too large to be considered planets, but not large enough to sustain full fusion like the Sun. Jupiter is not a brown dwarf, but it is closer to that category than any other planet in the solar system. It sits at the edge between two worlds, between planets and stars. And that position defines everything about it. Because deep inside Jupiter, the conditions are extreme enough to resemble what happens in stellar environments. High pressure, high temperature, dense material, but not enough to ignite fusion. It is as if Jupiter is constantly on the edge of becoming something greater, but never crossing that line. And that is what makes it so unique. Because it is not just a planet. It is a reminder of what could have been. Now imagine something different. Imagine Jupiter had formed slightly earlier, or in a slightly different region, where more material was available. Imagine it had grown larger. 10 times larger, 20 times larger. At some point, everything would change. The pressure at its core would increase beyond the current limits. The temperature would rise, the structure would shift. And eventually, fusion would begin. Jupiter would ignite. A second star in the solar system. The night sky on Earth would be different. Days would be brighter. Shadows would form in new directions. The entire balance of the solar system would change. Orbits would shift. Temperatures would rise. Life, as it developed on Earth, might not have survived. Because two stars, instead of one, would create a completely different environment. But that did not happen. Jupiter remained a planet. And because of that, the solar system became what it is today. Stable enough for Earth to form. Stable enough for life to exist. Jupiter did not become a star. And in that failure, it became something else. A guardian. Because its massive gravity pulls in dangerous objects, comets that could have struck Earth, asteroids that could have caused extinction-level events. Many of them are captured, redirected, or destroyed. Not all, but enough. Enough to influence the history of Earth. Enough to shape the path of life. This is why Jupiter is sometimes called the protector of the solar system. But it is not a perfect protector. Because sometimes it does the opposite. Its gravity can also send objects inward, toward the inner planets, toward Earth. Which means it is both a shield and a source of danger. A balance. Just like everything else about Jupiter. And this balance is what has allowed it to exist for billions of years without changing its fundamental nature. It remains massive, powerful, dominant, but incomplete. Not a star, not a solid world. Something in between. And as time continues, Jupiter will not remain entirely unchanged. The sun will evolve, the solar system will transform. And when that happens, Jupiter will face a future, just like every other object in space. But for now, it stands as it always has. A giant, a force, a boundary between what is and what could have been. And the more you understand it, the more you realize something strange. Jupiter is not just a planet you can study. It is a limit. A point where the universe almost created something different and stopped. And that moment still exists inside it. You are still looking at Jupiter, but now time begins to stretch far beyond anything you have considered so far, because everything you have seen, its storms, its gravity, its magnetic field, its moons, all of it exists in a moment that feels permanent. But it isn't. Jupiter has existed for billions of years, formed from the same cloud that created the sun and the rest of the solar system. Since then, it has remained relatively stable. Its size has not changed dramatically. Its structure has held together. Its storms have continued to form and disappear. From your perspective, it feels eternal. But even something as massive as Jupiter is part of a timeline that is still moving forward. Right now, the sun is stable. It shines steadily, providing energy across the solar system. Jupiter receives that energy, reflects part of it, and emits some of its own heat from deep within. Everything is balanced. But the sun will not remain like this forever. Over time, its core changes. Its energy output increases. Slowly at first, then more noticeably. And while the inner planets feel these changes more directly, Jupiter is not completely untouched. As the sun grows brighter, the temperature in the outer regions of the solar system increases slightly. Not enough to dramatically alter Jupiter's structure, but enough to affect its outer atmosphere. The clouds shift. The chemistry changes. Small differences spread over millions of years. But this is only the beginning, because the real change comes much later. Billions of years into the future, the sun will enter a new phase, the red giant phase. When this happens, the sun will expand massively. Its outer layers will stretch outward, reaching into the inner solar system, consuming Mercury, then Venus, and possibly even Earth. But Jupiter is farther away. It will not be consumed. Instead, it will experience something different. As the sun expands, it also loses mass. Through powerful stellar winds, material is pushed outward into space. And this changes the gravitational balance of the entire solar system. The sun becomes less massive, its pull weakens, which means the orbits of the planets shift. Jupiter's orbit will move outward, slowly but significantly. It will drift farther from the sun into a colder region of space. At the same time, the sun's expanded outer layers will increase the amount of radiation reaching Jupiter for a period of time. Its upper atmosphere may heat up. Its cloud structure may change. Its storms may become more active or behave differently. But these changes are temporary, because after the red giant phase, the sun will collapse. Its outer layers will be expelled into space, forming a planetary nebula. And at the center, a white dwarf will remain, a small, dense, fading star. And around it, Jupiter will still exist. But everything around it will be different. the inner planets will be gone, destroyed, consumed, or reduced to fragments. The solar system, as you know it, will no longer exist. What remains is a quieter system. A white dwarf at the center. Jupiter, still orbiting, its moons still present. But the energy that once defined the system will be gone. The sun will no longer shine with the same intensity, no longer drive the same processes, no longer dominate the environment. Jupiter, which once existed under the influence of a powerful star, will now orbit something much dimmer. And over time, even that will change. The white dwarf will cool, slowly, over billions, then trillions of years. Its light will fade, its heat will decrease, and the solar system will become darker, colder, more silent. Jupiter's internal heat will still exist, but it will slowly radiate away. Its storms, driven in part by that internal energy, will weaken. The motion will slow, not completely, but enough that the planet begins to feel quieter, less active. The magnetic field may weaken over time as the internal processes that generate it slow down. The radiation environment will fade, and the entire system will move toward a state of stillness. But even then, Jupiter will not disappear. It is too massive, too stable. It will continue to orbit, continue to exist. Long after the sun has evaded, long after the inner planets are gone, it will become a relic, a remnant of a system that once existed. A giant world, drifting in a colder, darker region of space. And this is what makes Jupiter so extraordinary. Not just what it is now, but what it will become. Because while Earth will transform completely, losing everything that once defined it, Jupiter will remain. Changed, yes, but still there. A survivor, a witness to the evolution of the entire solar system. And as time continues, even beyond that, the universe itself will change. Galaxies will move, stars will die, new systems will form. And Jupiter, or what remains of it, will continue its journey through that ever-changing cosmos, not as something special, not as something protected, but as part of the same process that shapes everything, a process that never stops, a process that continues long after every storm has faded, long after every light has dimmed, a process that carries even the largest worlds into the unknown. You are still looking at Jupiter, but now the scale stretches beyond the planet itself, because everything you've seen so far, its storms, its gravity, its moons, its magnetic field, exists inside a larger structure, the solar system, and Jupiter does not just exist within it, it shapes it. For billions of years, Jupiter has acted like a boundary, a dividing line between the inner planets, small, rocky, fragile, and the outer regions filled with gas giants, ice giants, and distant objects drifting in the darkness. Inside its orbit, worlds like Earth formed, stable, relatively calm, capable of supporting life. Outside its orbit, everything is different, colder, more distant, more chaotic. And Jupiter sits right between those two regions, not by accident, because during the early formation of the solar system, Jupiter did not stay in one place. It moved, very slightly, but enough to change everything. Some models suggest that Jupiter may have migrated inward, then outward again, during its early history. And that movement reshaped the entire solar system. It scattered material. It prevented planets from forming in certain regions. It pushed and pulled on the building blocks of worlds. Which means, without Jupiter, Earth might not exist at all. Or if it did, it might be completely different. This is what makes Jupiter more than just a planet. It is part of the reason the solar system looks the way it does. And that influence continues, even now. Far beyond the visible planets, there are regions filled with icy bodies, comets, fragments left over from the formation of the solar system, the Kuiper Belt, the Oort cloud, vast reservoirs of material stretching far into space, and from time to time, objects from those regions begin to move inward. They fall, pulled by gravity, sometimes toward the inner planets, sometimes toward the Sun, and often toward Jupiter, because its gravity is the strongest planetary force in the system. It captures some of these objects, deflects others, alters their paths in ways that can last for millions of years. Some are sent away, ejected from the solar system entirely, which means Jupiter does something extraordinary. It cleans. It removes material. It acts as a kind of filter, shaping the population of objects that exist within the solar system. But this process is not perfect. Sometimes its influence sends objects inward, toward Earth, which means it is both a protector and a source of danger, a balance that has existed for billions of years. Now, imagine this system far into the future. The Sun has changed. The inner planets are gone. The light that once defined everything is fading. And Jupiter still remains? But now its role is different. There are no inner planets to protect, no Earth to influence, no delicate balance to maintain. The system is quieter, but not empty, because the outer regions still exist. The distant objects still move. Gravity still shapes their paths. And Jupiter still interacts with them. Even in a darker, colder system, its influence continues. Objects pass near it. Some are captured, some are redirected, some are sent away forever. The process never stops, because gravity does not stop. And as time moves forward, something even larger begins to happen. The solar system itself begins to drift. The galaxy is not still. Stars move. Systems interact. Distances change over billions of years. And occasionally, another star passes nearby. Not close enough to collide, but close enough to disturb the outer regions of the solar system. To pull on the Oort cloud, to send waves of comets inward. And when that happens, Jupiter responds. Its gravity interacts with this incoming material, redirecting it, capturing some of it, ejecting others. Once again, shaping the system. Even in its final stages, even when everything else has changed, Jupiter remains active. Not through storms, not through visible motion, but through influence, through gravity. And this is what makes Jupiter different from any other planet. Because its importance is not limited to itself. It extends outward, across the entire system, across time, across the history of everything that formed around it. And even when the solar system is no longer what it once was, Jupiter will still be there. A giant, a force, a reminder of a time when everything was more active, more alive, more complex. And as it continues its journey through a changing galaxy, through a universe that never stops evolving, one truth becomes clear. Jupiter is not just part of the solar system. It is one of the reasons it exists at all. And even in the far future, its influence will never completely disappear. You are still looking at Jupiter, but now the idea of time stretches so far that even this giant world begins to feel temporary. For billions of years, Jupiter has remained one of the most stable objects in the solar system. While smaller planets changed, lost atmospheres, or evolved dramatically, Jupiter held its structure. Its storms continued. Its gravity dominated. Its presence shaped everything around it. But even Jupiter exists inside a universe that does not stop changing. Time moves forward, not in millions of years anymore, but in billions, then trillions. The sun is no longer what it once was. Its red giant phase has passed. Its outer layers have drifted away. And what remains at the center of the system is a white dwarf, small, dense, and slowly cooling. Around it, the solar system is quiet. The inner planets are gone. No Mercury, no Venus, no Earth. Only distant survivors remain. And among them, Jupiter. It still orbits, still follows the path it has followed for billions of years. But that path is wider now. The sun lost mass during its transformation, and that loss weakened its gravitational pull. Jupiter drifted outward, slowly moving into a colder region of space. The light is different now, dimmer, weaker. The white dwarf still glows, but it does not dominate the system like the sun once did. Jupiter is colder. Its upper atmosphere, once influenced by solar energy, now relies almost entirely on internal heat. But that heat is not infinite. Over time, it radiates away. The storms, once powerful and endless, begin to weaken. Not suddenly, not dramatically, but gradually. The motion slows, the energy fades. The bands across Jupiter's surface become less defined, less active. The great red spot, that ancient storm, may disappear completely. After centuries, after millennia, after millions of years, it fades, because nothing on Jupiter is truly permanent. Even the longest-lasting storms eventually end. The magnetic field begins to weaken. The internal motion that generates it slows as the planet cools. The radiation environment fades. The space around Jupiter becomes quieter, less dangerous, less active. And yet, Jupiter remains. Even in this quieter state, it is still massive, still dominant, still capable of shaping the space around it. Objects from the outer regions still pass nearby, comets, fragments, remnants of the solar system's formation. Jupiter still interacts with them. It captures some, deflects others. Gravity continues its work. Even when everything else has slowed, gravity remains. And then, time moves even further, beyond billions of years, into trillions. The white dwarf continues to cool. Its light fades almost completely. The solar system becomes dark. Jupiter, now far from its original position, exists in near total darkness. Its surface no longer reflects strong light. Its clouds are barely visible. From a distance, it is just a shadow, a massive, silent world drifting in space. And yet, it still exists. Because Jupiter is built to last. Its mass, its structure, its composition allow it to survive far longer than smaller planets ever could. But even this is not forever. Because the universe itself continues to change. Galaxies move, stars pass near each other. Gravitational interactions reshape systems over unimaginable periods of time. And eventually, something happens. A passing star moves close enough to disturb the outer solar system. Not close enough to destroy everything, but close enough to change orbits. Jupiter's path shifts, slightly at first, then more. The stable orbit it followed for trillions of years begins to change. It may move farther outward, or, in some scenarios, it may be ejected completely, thrown out of the solar system, becoming something else, a rogue planet, a world without a star, drifting through interstellar space, alone. And this is where the story changes again. Because Jupiter, which once dominated a system, may become a traveler, moving through the galaxy without orbit, without a central star, guided only by the gravitational pull of distant objects. And even then, it continues, because nothing stops. Not the motion, not the change. Even in isolation, Jupiter remains part of the universe, a remnant of a system that once existed, a giant world carrying within it the history of everything it shaped. And as it drifts through darkness, through space, through time, one truth becomes clear. Even something as massive, as powerful, as enduring as Jupiter is not permanent. It is part of a larger process, a process where worlds form, evolve, and eventually move on. And Jupiter, like everything else, will follow that path. You are no longer looking at Jupiter as a planet. You are looking at a story that has stretched across billions, then trillions of years. A world that once dominated its system, shaped orbits, controlled the motion of countless objects, and now exists in a completely different state. Jupiter did not disappear, it changed. At the beginning, it was a force of formation, a giant gathering gas and dust, influencing everything around it, shaping the structure of the solar system itself. Then it became a system, storms without end, moons that felt like worlds, a magnetic field that reached far into space, a planet that was not just a place, but an environment. And then time moved forward, the sun changed, the inner planets vanished, the light faded, and Jupiter remained. But even that stability was temporary. Its storms weakened, its heat slowly faded, its magnetic field lost its strength. What once felt endless began to slow. And eventually, it became something quieter. Not dead, not gone, but silent. A massive world drifting in darkness, holding on to the last traces of its internal energy, long after the system that created it had transformed. And then, even that was not the end, because the universe does not allow stillness forever. A passing star, a distant gravitational interaction, something subtle, something slow, began to change its path. Jupiter moved, not within a system anymore, but through the galaxy itself, a rogue planet. No sun, no orbit, no constant source of light. Only motion, drifting through interstellar space, surrounded by darkness, carrying with it the history of billions of years. And yet, even in that isolation, it still exists. Because Jupiter is built to endure. Its mass keeps it intact, its structure holds together, its core still contains heat, slowly fading, but still present. It is no longer a giant under sunlight. It is a giant in the dark. And still, the story does not end. Because somewhere, far ahead, something else may happen. A new star, a new system, a region of space where gravity begins to gather material again. And if Jupiter passes close enough, it could be captured, pulled into orbit around a new star, becoming part of a new system, not as the same object, not as the same influence, but as something carried forward into a different environment. And even if that never happens, it continues to drift, because motion never stops. Time never stops, and the universe never stops changing. This is the final truth. Jupiter was never just a planet. It was part of a process, from formation to dominance to survival to isolation and beyond. Because nothing in the universe exists in a single state forever. Everything evolves, everything transforms, everything becomes something else. And even a giant like Jupiter is just one step in an endless chain. A chain that connects stars, planets, systems, and the vast emptiness between them. A chain that never breaks. A chain that continues long after every storm fades, long after every light disappears, long after every world feels like it has reached its end. Because there is no final moment, only continuation, only the quiet movement of everything into something new. And now, you are no longer looking at Jupiter. You are looking at the universe itself, becoming something else, again and again, forever.